Hello, my name is Mike Higgins. I'm the Director of Sales for Phoseon Technology. And today I'm going to talk to you about upgrading your Novax M to UV LED, some of the compelling reasons to consider doing so, and how to go about that process today. So Phoseon has been working with OMSO for over 12 years, supplying UV LED curing lamps to OMSO to be installed on various screen printing machines that they build. The Novax M was one of the more popular machines, and there are hundreds of them that exist out in the field today. Close engineering work between the folks at OMSO as well as at Phoseon is really what led to the installation and commercialization of some of the first LED curing screen machines in the world. So over that time, OMSO has been one of the largest users of our water-cooled lamps and now has migrated onto our air-cooled lamps for their designs. And we continue to see a lot of success and believe that the future is going to move 100% over to LED. The value proposition for LED when it comes to upgrading the Novax M is quite significant. One of the biggest impacts on your business is going to be higher throughput and yield. The LED systems offer more uptime and more operational availability than the current UV fusion microwave systems. The LED lamps are not generating any heat. They are instant on off, and these two factors are what are going to contribute to less scrap. The low heat aspect of the LED lamps is very significant. Right out of the gate, you'll notice that the lamps themselves are not generating any infrared heat, and that the light that's coming out of the lamp is all in the high UVA spectrum. This not only allows you to use substrates that are more susceptible to heat, but it also reduces the overall heat load on the machine itself. Today, the fusion microwave lamp is heating up various different parts that are surrounding that curing area. And that is going to significantly affect the performance of those parts and of that machine long term. When you switch to a UV LED system, you remove all of that heat, and you're only using UV light when you're actually curing. So it's a very efficient way to operate the system. One of the other big advantages of LED compared to the existing UV mercury lamps is that you're going to get better cure on whites and blacks. TiO2 and carbon black are pigments that absorb the majority of the UV wavelengths that are emitted by a fusion microwave lamp. UV LED is emitting only high UVA wavelength, and that wavelength, 395 nanometers, is not absorbed by TiO2 and is absorbed very little by carbon black. So more of that UV light is going to get to the photoinitiator and the rest of the UV curable package that's inside of that ink and create more consistent cross-linking. So LED is going to allow you to use more opaque white inks. And that, and to my understanding, is one of the areas that is difficult to key in or hone in on with today's systems. But if you consider a UV LED system, you're going to get much better cure on those whites and black inks. Faster speeds and improved adhesion are also benefits of the LED system. Some applications require a 24-hour waiting period to determine if the ink has adhered to the bottle and if that project is going to pass performance property testing. Well, with the long, high UVA wavelength of LED, your adhesion is going to be improved so much so that there is no waiting period to determine whether or not the ink is going to stick. That in turn is going to reduce quite a bit less scrap for your operation. As soon as that bottle comes off the line, you can test it for adhesion and get your results very quickly, as opposed to waiting 24 hours to determine whether or not the ink is sticking. This is consistent curing and irradiance control is a key benefit of the LED curing system. Once you get it installed and you dial it into the correct amount of power required for that job, it's going to remain consistent day in and day out with no variability or changes. Overall operational costs, you've got savings of about 60% plus on your total energy consumption. That includes the LED lamp as well as the exhaust system that you will not need with the LEDs that you do currently need with your Mercury system. Without that exhaust system, the overall infrastructure required for your curing station is significantly reduced. Our Phoseon LED curing lamps also run off of 48-volt DC power supplies, standard power supplies that you would find off the shelf. These are not only reliable, but they are very compact and lightweight. And when you eliminate all of the lamp-related consumables that come with a microwave system, you've got savings on an annual basis that are going to add up to quite a bit. LED also contributes very positively to the eco-friendly and sustainable nature of business today. There's no mercury, there's no UVC, and you've got lifetimes that are about 20 times longer than your typical microwave lamps today. To expand a bit on that point, from a sustainability perspective, every major brand has some sort of sustainability objective today, and they are putting pressure on their suppliers to meet various different types of eco-friendly standards. And they're looking for suppliers to offer them solutions as to how they can promote the fact that they're reducing their carbon footprint. Reducing CO2 emissions is a big part of this. That can offset some regulatory costs that, if they're not already in place, are certainly coming down the line. And to give you some numbers, about 23 tons of CO2 are generated per year from 3 microwave systems that would be on your Novax M today. 23 tons of CO2 per year. All of that can be removed with switching to UV LED. So if you've got 2, 3, 4 machines that could be upgraded, your impact of total tons per year of CO2 emissions can be reduced drastically. So no mercury, no greenhouse gas emissions at all with the UV LED. There's no UVC, which means there's no ozone. And ozone is that odor that you smell from the UV mercury lamp today by the machine. The ozone has a very distinct smell to it. And if you're in it day to day, you don't notice it nearly as much. But if you're an outsider who walks into a facility, one of the first things you notice is that ozone smell. All of that goes away with UV LED. You don't have any ozone whatsoever. And that is going to make a big difference in the workplace safety factor. The LED lamp itself, when it does reach end of life, is about 90% recyclable. So although this is many years down the line, it's important to recognize that from cradle to grave, that the LED light source is going to be much like your desktop computer. When you're tossing it out, you don't just throw it in the trash, you take it to be recycled. Those components are removed and then used in more modern day applications. Operator safety, ozone is a big part of it. Heat generation is a big part of it. There's also the fact that UVC and UVB wavelengths are harmful to the eyes and to the face or to the skin. There are no UVB or UVC wavelengths generated with LED. Therefore, from an operator safety perspective, you've got a much better working environment. In addition to that, without the exhaust fans, you're reducing the overall amount of noise that's generated by the machine. The UV LED lamps have fans built inside of them that are very quiet compared to the alternative, and they are only going to be on when the lamp itself is actually on. So green from a sustainability factor is one thing, but green as far as ROI is really what's going to drive decisions today. The Fusion microwave units are consuming about 7.1 kilowatt hours on an average basis, running off of 220 volt 3-phase power. Your replacement components for a microwave system range anywhere from $2,000 to $3,000 per year per unit. And that is a reoccurring cost. Even if you're operating the system efficiently and correctly, you're still going to have to rebuild the unit every so many years in order for it to output the power needed to cure. The Fj200 16 watt per centimeter squared unit is the LED lamp of choice that OMSO uses to upgrade the Novax M. If you're averaging an on time of about 55% for your machine cycle, your power consumption is going to be roughly around 2.5 kilowatt hours using single phase 60 hertz power. There are no external extraction fans necessary with the unit, nor is there any ozone that needs to be exhausted out of the system, no heat generated. And the replaceable parts. The two areas of maintenance for UV LED are going to be one, monitoring, cleaning, and sometimes replacing the air filters on top of the lamp. And two is cleaning the emitting window itself from time to time on the bottom of the lamp. And we'll take a look at what one of these lamps looks like here in a couple slides. Expanding on the ROI, your energy consumption is going to be roughly 65% less starting right out of the gate on day one. Your parts savings are roughly between $2,000 and $3,000 per year. And overall, you're just going to have less downtime, more consistent cure, and less scrap. This number is going to vary from operation to operation. But what we can say is that it's going to be a very big number compared to what you are producing today. No heat is going to have an impact on the substrate as well as your HVA system inside the facility. And when you take a look at the labor costs and the maintenance associated and the loss of downtime, production downtime with UV mercury, you're looking at about less than one third of the annual operating costs for UV LED compared to UV mercury. All of these things add up to an ROI expectation, which is less than 2 years. You're also going to extend the lifetime of your Novax M asset by at least 5 years with an upgraded LED curing system. And you're going to modernize your facility to meet future demands. The environmental aspect is one piece of it. Reducing the infrastructure would be another piece of it. Reducing scrap. All of these things are contributing in a very positive way to the future demands of your facility and are going to create real financial savings that are going to hit your bottom line and are going to hit very quickly once you get the lamps installed. This is a look at the Fj200 LED curing lamp. At the bottom, you'll see where the light is emitted. These are the LED diodes at the bottom of the lamp with the protective glass piece on top of it. This area down here on the bottom of the lamp is very well sealed to reduce from ink ingress or particulate getting in there. The white filters at top are going to filter the ambient air that's brought in. There are fans inside of this lamp, so air is pulled through the filter. It is blown through a heat sink, which is on the back end of these LED diodes, and then it's blown straight out the top of the lamp itself. The Fj200 is a very proven retrofit solution for the Novax M. OMSO has done many of these retrofits already and have units in-house on Novax M machines today in Northern Kentucky that they would be happy to bring you in and show off what the capabilities of the system are. Power is adjustable from 10% to 100%, so you are really future-proofing your design with more power that can be utilized down the line if you were to need it for a future application, whether it's higher speed, whether it's a unique, difficult to cure ink or coating that may be going on to the bottles. Peak irradiance, the standard is 16 watts per centimeter squared, but we do offer a lamp that's 20 watts per centimeter squared now as well. If the application required it, we can hit it with more power. And the fans that are built into the lamp are very quiet. They're not going to add noise to your operation. Most likely, they really are hardly going to be heard compared to some of the other things in your operation. So the whole package itself is really going to contribute in a very positive way to operator satisfaction, as well as consistent curing and performance over time. The process to retrofit is very easy. OMSO has done a lot of these to date. Each station takes roughly 4 hours to put the lamps in place, to run the wiring and mount the power supplies. These two pictures really tell a good story. On the bottom left, you can see the UV microwave unit here. It's a large box, very heavily protected. You've got a big exhaust fan that's pulling heat as well as ozone out of the facility up top. Versus the picture here on the right is the Fj200. It's a much more compact lamp. The green connector up here is where the power cables will connect. There's no cables pictured here. But you can see by comparing these two units, you're getting the same amount of curing area coverage, but in a package that's roughly half the size of what you have today. Contact information for OMSO would be to IDA if you'd like to get a quote that is specific to your system. Scott is welcome to hosting anybody who would like to come into their facility in Northern Kentucky and run some trials, see the Novax-M machine running, fully equipped with UV LED. And that'll give you a real true sense as to what the performance capabilities are of the LED system compared to the existing UV mercury system. So to summarize, converting to an LED solid state technology is going to advance your capabilities by giving you only the amount of UV power that's required to cure your ink chemistry. Your lamps are only going to be on when they need to be. And this is a very stable and precise process that's repeatable day in, day out. The operating economics of this system are significant, whether it's energy savings, whether it's reduced temperatures that are reducing scrap, longer lifetime that's going to be 20 times longer than your current UV mercury system. Those operating economics tend to add up to an ROI of less than 2 years for the system. And from an environmental perspective, with no mercury and a safer workplace, you're really checking a lot of boxes that all companies are looking for these days when you switch to a UV LED curing technology. With that, I thank you for your time and encourage you to reach out to OMSO or myself, Mike Higgins at Phoseon Technology, with any questions. We are here to support you, and we are here to really continue to drive this technology forward into the future. Phoseon is based in Portland, Oregon. All of our manufacturing is in the United States, and we have been a long-term partner of OMSO and are fully committed to UV LED curing and screen printing. Thank you.